All right, hello class. This is for my 8th graders on Monday, May 11th. Tomorrow we are going to have a Zoom meeting. I'm going to have the addresses and stuff go out tonight on Google Classroom, so make sure you check that out. So we were looking at distance and triangles and the Pythagorean theorem and everything like that on the last lesson. So today we're gonna start moving on from that. I'll still take questions and maybe go over distance a little bit more on our Zoom lesson tomorrow. There is a concept checked up in Google Classroom. Make sure you check that out. I want to make sure everybody completes that. That is going to be graded. And so we're going to start a new topic today. Lesson 1, translations. All right, so at the very beginning here, it says a transformation is an operation that maps an original geometric figure, the pre-image, onto a new figure called the image. A translation slides a figure from one position to another without turning it. Okay, so a lot of these transformations, as they call them, is used in animations, movies, video games, everything like that. They're used in all those kinds of industries. So if anybody's thinking about going into that industry, you may want to think about how the geometric shapes are used. I think I've said before that everything breaks down to a triangle, and that's why we were studying triangles and the Pythagorean theorem and the distance formula. So in our packets, so I started filling this out a little bit. I'm going to go through and tell you what to write down here. So it says, scan the lesson, complete the graphic organizer. So if you want to, you can pause it and scan through it and see what it looks like. I am going to go through it though. So in my own words, I put down a movement of a figure. So transformation is just a movement of a figure. Excuse me. 3 characteristics that I found. There's a vertical shift, so that means it can go up or down, because that's vertical is like up or down. I always think about that, about jumping, that's your vertical. A horizontal shift, so that means from left to right, so that's going to be my x value, where the vertical shift is going to be my y value, okay? And then if I did draw a couple examples down here, this is one example. So you have to move for a transfer, or for our translation, I apologize, for our translation, you have to have, if you're going to move a line to the right, you want to try to have it go in the same direction and in the same length. And that's considered a translation. Whereas if lines went in different directions and different lengths, you would get something that wouldn't really be a slide or anything like that, because these two shapes are not necessarily identical, whereas these two shapes are. Okay? So looking down here, describe the motion involved in moving the design from A to A prime. So if we're looking over here at the right, at this computer, so when we go from A to A prime, what are we doing? Okay, this is why I said a vertical shift and a horizontal shift up above. Because in this picture, it looks like we go to the right one, and then we go down one. So there's a shift happening. And so if we took out this one that's in between A and A prime, that's what we call that little mark that's above the A. That's considered an A prime. That's what we say. So here, if we took out the middle image, it looks like it kind of slides down and to the right, correct? Kind of like a slide. And that's what animators do in movies, in video games, and a lot of things. Compare the size, shape, and orientation of the design piece. So the size should be the same, identical. Shape, same, identical. Orientation, what do you think orientation means? Orientation does mean the position of it. So for instance, if I have my phone, if I move it, alright, there's no change, correct? Everything's the same. Orientation is if I spin it. So if this is my original one, orientation, I would flip it upside down, because then I'm changing the orientation of it, correct? So there's no change in orientation on this as well. Okay, turn the page. Alright, so translation in the coordinate planes. Now we're going to be looking at the x and y values. And this is how you can figure out a translation of an object. Since there's a vertical shift and a horizontal shift, there's going to be a connection with the y-axis and the x-axis. And since y goes up and down, this is going to affect the vertical shift. And the x, since this is left to right, that's going to affect the horizontal shift. Okay? So when we look over here, if our original coordinate is x and y for a point, whatever point it is, x, y, okay, any point. To get a move, if we just add something to A and add something to B, if we add something to A, that means we're going to move X, we're going to move left or right A times. And for Y, we're going to move up or down B times. Okay? So this is kind of like a general rule. We're going to get it more into applications and examples and things like that coming up here. When translating a figure, every point of the preimage is moved the same distance and in the same direction. The image and the preimage are congruent. Congruent figures have the same shape and the same size. So that means they are identical. So, line segments in the preimage have the same length as line segments in the image. Angles in the preimage have the same measure as angles in the image. So that means everything's moving. Okay, but they're the exact same. It's a slide. Okay, kind of like when you slide across the ice, your footprints don't move, right? I mean, when you're trying to get your balance and everything like that. But you could just stand there and your feet wouldn't move, but you would slide. Your feet wouldn't change angle. That's the same idea with these translations. So now we're going to graph triangle JKL with vertices -3, 4, 1, 3, -4, and y. So those are the points of our original pre-image. Then graph the image of JKL after a translation 2 units right. So right away I'm going to underline that 2 units right. What do you think that means? Does that mean I'm going to go up or down or left or right? Okay, hopefully you said right. And if I go 2 units right, that means I'm going to affect the x variable, and that means I'm going to add 2 to it. Okay? And then I'm going to keep reading, and 5 units down. So if I go 5 units down, that means that's affecting my vertical, right? My up and down, and that's our y. And so if we go 5 units down, that means if we go down in our y value, that means we're going to go y minus 5. Okay? And those are the 2 equations that we're going to use to find our new points. Okay, and that's what we do down here. So it says move each vertex of the triangle 2 units right and 5 units down. Use prime symbols for the vertices of the image. And that's what they do here. Here's my J. I'm going to go 2 to the right. That's x plus 2. And then y minus 5. So that means I'm going to go 5 down. And then there's my new point. For my L, I'm going to start here. I go 2 units to the right, 1, 2. And then I have to go 5 units down. 1, 2, 3, 4, 5. Right here, okay? And they mark these on here for you. Same with K, 2 to the right, 5 down. And if you look at it, these two should be the exact same. Okay, and that's what they show you over here. So now you have your new points for your new image. Okay? And that's what they give you. So our J prime is -1, -1. Okay? And then our K prime is 3, -2. So to get here, I go 3, -2. And then lastly is my L prime, and that's -2, -4. Okay? So try to pause it and try A on your own. I will go through it. Okay, hopefully you tried it on your own. So we're going to be looking at this. Graph triangle ABC with vertices A4, -3, B0, 2, and C5, 1. I don't even have to graph those. Okay, I already know the coordinates, and that's important. Then graph its image after a translation of 4 units left. So if I'm going left, is that affecting my horizontal or my vertical axis? If I'm going left to right, that's going to be my horizontal axis. Okay, and if I go 4 units left, that means it's going to be affecting my x. And if I go 4 units left, that means I'm going to go minus 4. Okay, and that's what I'm going to do to whatever x values I have in these variables, or in my coordinates. Next, I go 3 units up. Okay, if I go 3 units up, that's affecting my vertical, my up and down. That's going to be my y. So I know that my y is going to go plus 3, because that's going to be 3 units up. So I know I'm going to add 3. And then I just, for every x variable, I plug it in, and I should have 3 new points. Okay, so for my first one, a prime. Okay. Excuse me. So if my x variable or coordinate is 4, what's 4 minus 4? 0. So that means my new x coordinate for my a prime is 0. Okay. Next is going to be my y. Negative 3 plus 3. Negative 3 plus 3 is 0. Okay, now I'm going to go to my b prime. Okay, 0, what am I doing to my x's? I'm subtracting 4, so 0 minus 4 is a negative 4. Comma. My y is 2 for my original b. 2 plus 3 is 5. Okay, and then for my last one, my c prime, I have 5 for my x. 5 minus 4 is 1. And then my y coordinate is a 1. 1 plus 3 is a 4. Alright, now I have to plot these points. Okay, so let's first go with 0, 0. So that's my a. And then b prime is negative 4, 5. So negative 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So up here. And then my last one is 1, 4. So I go 1, 1, 2, 3, 4. And though this would be, that is my image. Okay, and this is my a prime, b prime is over here, and then c prime right there. Okay, so you're just adding values to your x coordinate and your y coordinate. Okay, and sometimes you will be given a table. So if you turn it over, please, you'll see that you're going to have vertices. So a triangle has vertices -1, -2, 6, -3, and so on. Find the vertices of the new points after a translation of 2 units left and 1 unit up. And that's what they do down here. Okay, now they set up a table. So they know for the x value, you're going to be adding a -2 or just subtracting 2. And then for my y, I'm going to be adding 1 or adding 1. Yeah, right? And that's the vertical shift for my y, and that's the horizontal shift for my x. And then they get them, and then you get your new coordinates down here. So try B on your own, please. Try B on your own, please. Pause it. Oh, excuse me. All right, hopefully you tried it on your own. So for B, so I have my original coordinates. Find the vertices of the new coordinates. Given a translation of 4 units to the right. Alright, if I'm going 4 units to the right, that means I'm going to be changing my horizontal, correct? And that's my x value. And if I go to the right, that means I'm going to be going x plus 4. Okay? And then for my y, whoops, since I go 2 units down, you have to think about what's happening to your y value. What's happening to your y value on a graph? It's when you go down. Well, that means you're going to go -2, just like that. And then you're just going to apply each one of these formulas to each set of coordinates. Okay, so my new one, a prime, 0, 0, 0 plus 4 is 4, and then 0 minus 2 is -2, so that's my new coordinate. For my next one, b prime, 2 plus 4 for my x value, 2 plus 4